Hi guys, good morning. Can you hear me? Yeah. So let us start session. Yes. Last class about interpreter and compiler discussed. Yes. All these basics completed. Yes. Next about interpreter, compiler. Yes. This topic completed yesterday. Java introduction done. So here finally Java depends on both interpreter as well compiler. So finished. Yes. Today let us see about Java features. Java. Yes. See. So previous classes we discussed what is Java. Yes, what are the features of Java? These things, right? JDK 1.0. JDK 1.0 release with below features. JDK 1.0 release with below features. See, JDK 1.0 release with below features. First one, independent of platform, portability, group language, scalability, and security. Yes, to understand all these features here, last two classes we have discussed of some basics. To understand all these features here, we have discussed about some basics like yes, about voice, what is exactly voice, okay, what is front end, what is back end, next about languages, low level language, high level languages, okay. So this thing discussed. Next about interpreter compiler discussed. About interpreter compiler discussed. Okay. Yes. Next Java depends on interpreter compiler both. So this topic discussed. So now we can understand these features very clearly. Java is independent platform, portability, group language, scalability, and security. Now we can understand these features very clearly. Now let us start. First one, independent platform. Independent platform. Yes, independent platform. Yes, Java is an independent platform. See, Java is an independent platform. Yes, what does it mean? Yes, what does it mean? Java is an independent platform. Java is an independent platform. What does it mean? See here, platform means it's a OS. Platform means simply OS. Platform means yes means OS. Platform means operating system. Platform means operating system. Okay, so platform means operating system. Platform is operating system. So previous class we have discussed about OS. So what is OS? See operating system. OS. So OS is a platform. On top of it, we can run all the application software sites. So OS acting like a platform. OS like a platform. So what is OS? OS is a platform where we can run all the application software. So OS is a platform, right? Now here platform means operating system. So here platform means operating system. Java is an independent platform. What does it mean? Yes, platform means operating system. Platform means operating system. Okay, that means here Java is independent platform. Means here, yes, Java program, yes, Java program can run on any ways, any operating system. Okay, Java is independent platform. What does it mean? Means here, what does it mean? So the question, right, for this answer. So here platform means ways here. So independent platform means Java program can run on any operating system. Independent platform means a Java program can run on any ways. Java program can run anyways. Java program can run on anyways. That's the meaning of independent platform. Yes, now question is here. Question is how Java program yes made us independent platform, independent platform, independent platform. Okay, so this is question, right? So okay, fine. Java is independent platform. What does it mean? So independent platform means Java program can run on any base. Here platform means operating system. Platform means operating system. Okay. Yes, Java program can run on any ways. Independent platform means it works with any ways here. Same program running on different operating systems. It's independent platform. Okay. So it is same program. Yes, same program. Yes, running on different operating systems. Different operating systems. Different operating systems. That's the meaning of independent platform. Now question is here. How Java program made us independent platform? How? How Java made us independent platform? How? For this we should answer this one. This question we should answer. Okay. Yes, it's a interview questions here. How Java program made us independent platform? Okay. How Java made us independent platform? What's the reason behind of this? Okay. How Java program made us independent platform? Let us see. To answer this question here, first of all, you must hear the what is exe file. Yes, about exe file and dot class file knowledge. So about exe file and dot class file knowledge. So once you have the exe file and dot class file knowledge, then you can understand this question here. Yes, to answer this question here. Yes, to answer this question here. Now, yes, you must have this exe file and dot class file knowledge. Once you have this knowledge here, what is exe file? What is dot class file? So once you know this one here, now you can answer this one here. So once you know this one here, you can answer this question here. Yes, what is exe file? What is dot class file? Let us say about exe file dot class file. Okay, exe file dot class file. Okay, what is an exe file? What is an exe file? What is an exe file? What's in exe file? Okay, exe file. Yes, for this answer. Yes, what is exe file? See, exe file is a binary code file. Exe file is a binary code file. Simple answer. What does exe file means? It's a binary code file. Yes, it's a system understandable language. System understandable language. System understandable language. Okay. Yes. So what is an exe file? What is an exe file? So exe file is a binary code file. Exe file is a binary code file. It's a system understandable language. So what is an exe file? Exe file is a binary code file. Yes, it's a system understandable language. It's a system understandable language. It's a system understandable language. Okay. Yes. See. So exe file means okay. Executive file. Okay. Fine. Yes. Here some question for you guys. Some question. Suppose exe file prepared. Exe file prepared. Question. exe file prepared on Windows OS. Windows OS. Question is exe file. Question is exe file prepared on Windows OS. Can I run on Linux OS? Can I run on Linux OS? That's a question. Anyone can answer this? Anyone have idea about it? Exe file prepared on Windows OS. Can I run on Linux OS? Same exe file. Exe file prepared on Windows OS. Can I run on Linux OS? Okay. So can I run on Linux OS? Exe file prepared on Windows OS. Can I run on Linux OS? No. Answer is no. Answer is no. Answer is no. Reason. What's the reason here? Reason. Yes, reason is exe file. Exe file is an OS dependent. OS dependent. OS dependent. Ex reason. Yes, reason is yes reason. Reason is exe file. Reason is exe file is an OS dependent. Exe file is a OS dependent here. Exe file is a OS dependent. Now immediately question why exe file is OS dependent? Why exe file is OS dependent? OS dependent. Okay. So why exe file is OS dependent? Yes, now we should answer this question here. Why exe file is OS dependent? What's the reason here? Why exe file is OS dependent? Okay. Yes. Now let's see. Yes. Suppose for example here, for example, let us take C program. Let us take C program. C program exe file. C program exe file prepared. C program exe file prepared on Windows OS. Then it contains. Yes, then it contains. See, for example, C program exe file. For example, C program exe file prepared on Windows OS. C program exe file prepared on Windows OS. Then it contains what? It contains what? See, binary code for C program. Binary code for C program. Binary code for C program plus binary code for C library. Binary code for C library plus binary code for OS library. Binary code for OS library. Okay. So you can by linking all of things generating exe file. Okay. C program exe file prepared in this phase. Yes. Then yes, C program exe file prepared on Windows phase. Then it contains binary code for C program, binary code for C library, and binary code for yes, Windows OS library. Here it's Windows OS library. Yes, let me show practically here. See. Yes, Windows. On Windows now. Let us try on C program. Suppose this is C program on Windows OS. C program Windows OS. Math.cpp. Okay, so it's a C program. Yes, A equal 10, B equal 20. Yes, C equal to A plus B, A minus B, and it's a program, right? C program. It's a C program. Simple C program. Yes, how the C program is working here? Let us see. Yes, backend. Let us go to backend. C drive, TC Turbo C. Yes, bin. Here it's available. Yes, math.cpp. See math.cpp. Okay, let me delete all the old files. See math.cpp. So this is program math.cpp. Okay, let us compile this. Alt C. Compilation. Compiles. When it compiles, see this backend one file generated. Yes, .obj object file generated. Property see this extension .obj. It's an object file. Okay, see this, it's an object file. So what is this object file here? What is this object file? This object file contains binary code for C program. See, this entire C program converts in binary format. Yes, your C program. So this complete C program. from wide main from top to bottom. This part simply converts in a binary format right to that object file, right into object file. So this math.obj. So this object file kind of what binary code for C program. Okay. For this next, yes, apart from this here, see here some include header files, include std data convert header file. Right? There are some header files, predefined header files, predefined header files. These predefined header files are from the C library. These are from the C library. These header files also having some binary codes. std data. Okay, it's having binary code. Quantity these are having binary code. These header files are from C library. These header files are from C library. So these also having some binary codes. Binary codes. Okay. So header files means C library binary code. It says C library binary codes. C library binary codes. And your program binary code. C program binary code. This math that to be right. Okay. Now when you run this, what happens here? Run it. See, first of all, exe file created here. The application exe math.exe file created. See the .exe file created. Okay. Now what happens here? How that exe file created here? How that exe file created? So at the time of creation of how that exe file here. See. So when you try to run this, it will create exe file. How that exe file creates here? If that C compiler simply taking binary code for C program means that math.obj file. So math.obj, that object file, binary code for your C program, binary code. So taking binary code of this math.obj. So binary code of C program. Okay. So binary code of C program. For the C program binary code math.obj plus binary code for this library. Binary code for std and convert. Okay. So binary code for C program. Okay, means that math.obj file plus binary code for C library, std these other files, library here, that binary codes. Apart from this, OS library, binary code for Windows OS library, binary code for Windows OS library. See, at the beginning we have discussed one topic here. See, every operating system has its own libraries. Every OS has its own libraries to communicate between application software and hardware components, right? Okay. Yes. So libraries, OS library. Okay, this library. This contains input output functions here. Okay. See, every program has to link with OS library before going to run. Linking with OS library. Otherwise cannot run here. Program has to link compulsory. Okay. Every program, even Java program also, C program, Hadoop or database, Python, whatever, all these programs, yes, all these programs, okay, all these programs should link with OS library. Okay, every program compulsory. So every program has to link with OS library. Without linking with OS library, it cannot communicate with hardware. These programs communicating with output device, right? Input output devices. For this purpose, yes, linking with OS library. Okay, these programs can communicate with hardware components through the OS library only here. Through the OS library. Using OS library communicates with hardware here. Okay, so these programs have to link with OS library. So once linked with OS library, it can communicate with hardware components. Okay, so every program has to link with OS library before going to run it here. Okay, now same thing happening here. See this compiler, C compiler, it takes the binary code of your C program, binary code of C. So this binary code means that OBJ file. Yes, math.obj file, binary code for C program and binary code for C library, binary code for C library. So binary code for C library. Okay, so binary code for C library. So this binary code for C library. Okay, right? Yes, by linking all of these things here. Yes, so binary code for this library here, C library. By linking all of these things generates exe. Okay, so binary code for C program. Okay, this binary code for C library. Okay, That means here binary code of this is math.obj file. This contains binary code for our C program. Apart from this, now here another files like std and connet. They are binary. They also have a binary code, right? These are library files. These library files binary codes. Yes, math.obj binary code. Okay, next apart from OAS library, by linking all of this in generates binary codes, generates exe file. This is exactly exe file. Okay, yes, binary code for C program, binary code for C library, binary code for C program, next binary code for C library, and binary code for Windows OS library. By linking all of these things, it generates exe file. It generates exe file. Okay, right? So this is exe file. Okay, right? Yes, let us take one more example. Another example. Let us see one more example. One more example. One more example. C program exe file prepared on Linux base. Linux base. Linux base. Linux base. Then it contains what? See binary code for C program. Binary code for C library same. Binary code for Linux base library. Linux base library. See on Linux base also. Let me show that on Linux base. Now see on Linux base. Yes, here all of this is manually. Yes, if it is Windows base, here using some ID, right? Turbo C ID. So behind of Turbo C, all happens here. Okay, behind of this ID, everything happened automatically happened. Exe file creation and all this happens automatically here. Okay, exe file creation and everything happens automatically here. But in Linux base, you have to do manually creation of exe file. Now you can understand very clearly the exact exe file. What is exact exe file? Now you can understand very clearly. Login in Linux base. Linux base. Yes, on Linux base, yes, all are manually. You have to develop manually in here. Linux base. Yes, if it is manually, then you can understand very clearly. Compilation and creation of exe file, all are manually here. Yes. See, suppose ls, one second. Let me create one directory mkdir mnrub. Directory created ls cd mnrub, change to mnrub. Yes, present working directory mnrub ls nothing. See, you guys don't worry about present working directory ls and c. The Linux is not our topic. Our topic is about exe. Just you concentrate on exe. Leave about Linux base. Just you focus on exe file. Okay. See, present working directory mnro ls, its contents ls plus list nothing, empty. It's empty. Now I'm creating one C program. Zread test.c program. Okay, gedit test.c program. Test.c program. Test.c. Yes, very simple program I'm writing here. Yes, hash includes stdio.h. Okay, next hash include, yes, not necessary. Yes, next void main function. Yes, same that C program, addition, subtraction, multiplication, same C program I'm writing here also. Okay, here int a is equal to 10 suppose. Okay, next int yes b is equal to 20. Okay, next yes int c, declaring third variable. Okay, c is equal to a plus b, c equal to a plus b. Yes, here printf. Okay, addition. Yes, addition is equal to, yes, percentage d slash n, yes, closing bracket. Yes, c displaying c value result, c value displaying. Okay, yes, next c equal to, yes, now a minus b, c equal to a minus b, subtraction equal to, next subtraction equal to displaying c value. Next c equal to a into b, multiplication. Yes, multiplication equal to multiplication equal to C, right? So this is simple C program. So A equal to 10, B equal to 20 into C, C equal to A plus B. Yes. Addition equal to displaying C value. Yes. Next subtraction is equal to displaying C value. Multiplication is equal to displaying that C value, right? Yes. A plus B addition, A minus B subtraction, A into B multiplication. Very simple program. Okay. Yes. Now we should save it. Save and exit. Okay, right? Saved ls. See this test.c file created. Now we should compare it here. cc -c test.c compilation. Compile. Comparison result file is test.o. O means here it's a object file. O means it's a object file. O means it's a object file. Test.o like a Windows files here math.o is right. Like that in Linux also that object file created. Object file created. After creating object file, so you can compile no errors. Compile no errors. Object file create. This object file is what binding code for C program. That object file test.o. That object file contains this part. Your C program part. Only this part. This part. Object file test.o file. That object file contains only this part. This part converting into binding code. Binding code writing to test.o. So test out that object file contains but binary code for this C program. Binary code for C program. Correct. Next here this std IO data set file, right? This header file predefined header file. It's header file from the library C library. This header file also having binary codes. This header file also having some binary codes. Binary codes. Okay. Yes. Next. Now we should create exe file. cc-o. See, previously C means only compilation. It's a compilation option. It's only compilation option. No object file converting into exe file. Object file converting to exe file. Okay, cc-o. Suppose exe file name is, let us say project is exe name. Exe. Okay. Yes, object file is test.o. Right? No. Run it. No, C language compiler. CC means C language compiler. C compiler. C language compiler. So taking test.o file, yes, test.object file. Okay, now C language compiler, just it will take a test.o object file. Next, binary code for stdio data header file. Binary code for C library header file. Okay, so binary code for C program, binary code for C library, and binary code for Linux OS library. Linux OS also having its own library. By linking all of this in generating one exe file. That exe file name is project. Now let us run the project exe file. Project exe file. Yes, see this. Addition, subtraction, and multiplication got it right. Project exe file created. Project exe file create execute right. See that exe name can be anyone. Okay, that exe name. Yes, in case of project exe. In case of this name, it can be any name. ABC, ls. That ABC, it's exe file. /ABC. Running the right. Yes, execute addition, subtraction, multiplication got it right. So this exe file. Okay. Yes. Let me show what is exact this exe file. Project exe file. Yes, gedit. Yes, project. Let me open the exe file. Yes. Let me open the exe file. So exe file contains what? Here, it little bit time it will take it here because exe file. See, this is exe format. Binary code, right? Complete exe file. It's a system understandable language, binary format. It's a system understandable language, binary format. So this is machine language. Machine language. It's a system understandable language. Okay. Next, one more thing here. In Linux, there is a file command to check the type of the file. There is a file command to check the type of the file. Support test.c. What is test.c file? Say this test.c. C source. It's a C source program. Ask a text. Ask is a text and C source. C source file. Now let us check project, that project file here. So what's the type of project? Project file command projects. See projects. It's a executable file. Project is a executable file. It's a executable file. Correct. Next here x86 means a hardware information. On 8086 processor, this exe file created 64-bit OS. x86 means 8086 processor on 64-bit OS. On this machine, that exe file created. Next, in this exe file, CLD, yes, Linux, okay, x8664.s42. See, .s42. This is what this one. It's a Linux OS library. Linux based library. It's a Linux based library. So this exe will project exe. This project exe file contains what? Linux based library. I think now it's clear. Inside of this exe file, that Linux based library is there. A .so. It's extension for OS library. .2 means version, that is second version. Yes, maybe already first version or second version. This is second version of exe, that library. .so. This is OS library. Is a .so is an extension for the OS library. So the project exe file, executable file, yes, with Linux OS library. So this is about exe file. I hope you understand what is exactly exe file. Okay. Yes. See, if C program exe file prepared on Windows OS, then it contains binary code for C program, binary code for C library, binary code for Windows OS library. Okay, right? Suppose C program exe file prepared on Linux OS, then it contains binary code for C program, binary code for C library, binary code for Linux OS library. At Linux OS library. Yes, one more example. Suppose let's see one more example. C++. Let us take C++. C++ program exe file. C++ program exe file prepared on Windows OS. Windows OS. Windows OS. Windows OS. Then it contains what here? Binary code for C++ program. Okay. Binary code for C++ library. C++ also having its own library, like iOS team data header file. Okay, fstream data header file. There are some header files in C++ also. That library plus binary code for yes Windows OS library. Binary code for Windows OS library. The binary code for yes Windows OS library. Okay. Yes, C++ program exe file. C++ program exe file prepared on Windows OS. C++ program exe file prepared on Windows OS. Then it contains yes binary code for C++ program, binary code for C++ library, binary code for Windows OS library. That is complete exe file. Okay. Now let us see. So here how exe file running at different operations. For example, here test.exe file prepared on Windows OS, Windows OS. Then what happens? See here in these three cases, three examples. What is common point here? These three examples. What is common thing here? OS library linking with OS here linked with OS library. So here also linked with Linux OS library. Here linked with OS library. This is a common. So what happens here? Exe file. See exe file. Yes, always. Exe file. Yes, always. Exe file. Always. Yes, linking with OS library. Linking with OS library, right? Okay, it's happening here everywhere. Okay, all the cases exe file linking with OS library. All the cases exe file linking with OS library. So exe file always linking with OS library. Okay, suppose exe file test.exe file prepared in Windows OS, then it links with yes Windows OS library. So Windows links with Windows OS library. Okay, right? Windows OS library. Okay, right? Now this test.exe file running at different platforms, how it behaves. Suppose if you're running test.exe file on different platforms, how it behaves. Let us see this. So test.exe file Yes, working on different platforms, working on working on different operations, different operations. Let us see different operations. Okay, let us take different operations here, different platforms, different platforms. First, let us take Windows platform. Windows platform. Okay, here there is a hardware. In computer, there is a hardware, hardware. Okay, hardware. See, on top of hardware, yes, there is the Windows OS. On top of hardware, there is a Windows OS, right? Yes, on top of Windows OS, running now test.exe file. Okay, on top of which test.exe file, test.exe. See, Windows OS. Yeah, this is with Windows OS with Win library. That Win library, Windows OS library. Windows OS with Windows library. Okay. Not test.exe file. How it's working here? See, when you try to run test.exe file, see get test.exe file, test.exe file prepared in Windows OS. Then it links with Windows OS library. Okay. Not test. When you try to run test.exe file or Windows OS, what happens here? Now this test.exe file, it will try to call Win library. It will try to call Win library. It will try to call Win library, right? Win library, Win library, Win library. So here Win library available. Okay, test.exe file, it will try to call Windows OS library. Here it will try to call Windows OS library. Try to call Windows OS library. Windows OS library. Yes, available. Using this Windows OS library, it can communicate with hardware components. That's it. So successfully executing here. Since test.exe file linked with Windows OS library. Okay, since test.exe file, yes, linked with Windows OS library. Yes, simply it makes a call to Windows OS library. Yes, available. Same library here already available. Same library already available. Okay, since available, simply calling Windows OS library with the help of Windows OS library communicates with hardware components, means successfully executing. Successfully executing. Okay, let us take another platform. Another platform like Windows OS. Let us take Linux platform. Yes, how it's working on Linux platform. Let us see on Linux platform. Same program on Linux base. Same test.exe file with Windows OS library. Test.exe file. Yes, test.exe file. So with Win library. Working on different platforms, right? Yes, test.exe with Win library. Same test.exe will place on Linux base. What happens? Not let's take Linux base. Linux base with Linux library. Linux library. Okay, Linux base with Linux library. So okay, when you try to run test.exe file in Linux base, what happens here? Now here already test.exe file linked with Windows OS library. Already test.exe file linked with Windows OS library. Simply it makes it called Windows library. Yes, that link is fixed. That link is test.exe file once linked with Windows OS library. Always working with Windows OS library. It's a fixed link is fixed. Okay, that link is fixed. That is nothing but statically linking. Statically linking. Statically means fixed, no change. Statically fixed, no changes. Okay, since test.exe file is linked with Windows OS library, that link is fixed, never changes. So always it will try to call on Windows library when here. Since test.exe file linked with Windows OS library, so everywhere calling Windows library. Here try to call Windows library. Yes, here available. Then executing. Yes, on Linux OS also. Now this exe file it will try to call Windows OS library. On Linux OS also it will try to call Windows OS library, but here is not available. Okay, library is not matching. Since library is not matching, simply call fails. This call fails. It will try to call Windows OS library, but here is not available. Simply it fails. What happens test.exe? Here it fails. Here it fails here. Now let us take another platform. Another for suppose Mac OS. Let us take Mac OS. Yes, let us take Mac OS. Mac OS with Mac library. Mac OS with Mac library. Mac OS with Mac library. Okay, so Mac OS with Mac library. Okay, See, when you try to run same test.exe file and Mac OS, what happens? Here also it will try to call to Windows OS library test.exe file. Here also it will try to call to Windows OS library, but here Mac library, that OS is different. So library is not matching. Library is not matching. So again fails. This fails here. Yes, because library is not matching, simply fails. Here also library is not matching, fails. Here library matching, then executing, then executing. Okay. Similarly, suppose let us take one more platform, Unix platform. Let us take Unix base, Unix base, Unix base. Yes, Unix base with Unix library. So every base having its own library. Library is not same. Different operation, different libraries. Now here also, it will try to call Windows library, but here not matching. Library is not matching. Simply it fails. Simply it fails. Okay. Yes, that exe file linked with OS library is statically linking. Okay. See exe file. See exe file. Exe file. Yes, exe file statically, 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 yes, linking with statically, statically, yes, linking with OS library, OS library. That link never changes. Always, yes, always it will try to call same library. That link never changes. Exe file statically linking with OS library. Okay, since static linking with OS library here, yes, it's OS dependent. Okay, yes, exe file static links with OS library. So static linking with OS library here, yes, yes, since, since it is statically linking, statically linking, statically linking. Okay, statically, just wait. Yes, once you come to Java, Java is a dynamic linking. So once dynamic linking concept here, now you can understand it. Yes, once dynamic linking completed, you can understand static linking. Since, yes, since exe file, since exe file, since exe file, yes, since exe file is statically linking with OS library, OS library, OS library. Yes, it's a OS dependent. It's a OS dependent, OS dependent, OS dependent. That's here. Now let us go back to this. Let us answer these questions here. See, so Java program is independent platform. Java is independent of what does mention. Yes, platform is operating system. Platform is operating system. Java program can run on any ways. That means same Java program, same Java program, same Java program running on different operations. Same Java program, same Java program running on different operations. Okay, how Java program made us independent platform? To answer this question here, you must have the exe file dot class file knowledge. Exe file dot class. Yes, about exe file. What is in exe file here? Okay, yes, exe file is a binary code file. It's a system understandable language. See, exe file prepared on Windows OS. Can I run a Linux base? No. Answer is no. Reason? Yes, exe file is a OS dependent. Exe file is a, yes, exe file is OS dependent. Why exe file is OS dependent? Simple answer. Reason? Yes, it contains OS library. It contains OS library. Simple answer. It contains OS library. Very simple answer. Yes, it contains OS library. Okay, simple answer here. So why exe file is OS dependent? Why exe file is OS dependent? Simple answer. It contains OS library. It contains OS library. Okay, fine. Yes. Now let us come to this. Yes. Since exe file contains OS library, it's OS dependent here. So why exe file is OS dependent? Reason? Simple answer. Yes, it contains OS library. Since exe file contains OS library, it's OS dependent. Okay. Yes. C program with exe file. It's clear. Okay. Yes. Next, C program with Linux based library. C++ program Windows based library. So exe file always linking with OS library. Okay, exe file always linking with OS library. Okay, right? Yes. So you can same exe file running on different operations, it fails. Yes, Windows based exe file running on only Windows based. It cannot run on other operations. Okay, reason exe file statically linking with OS library. Statically means fixed. That link fixed. Link never changes. Statical linking. Since exe file is statical linking with OS library, yes, it's a OS dependent. Yes, it's a OS dependent. Yes, statical linking. Now you can understand. Just wait for a minute. You can understand clearly what is statical linking. What is statical linking? I'll repeat point once again. Yes, now let us start Java. Let's take Java program. Okay. Yes, Java. Yes, Java, same example. Let us take same examples. First, like C program, Java program, like C, Java program, Java program. Okay. See here, Java program, yes, exe file, not exe file, Java is a dot class file. Java is a dot class file. Yesterday discussed it. After compilation, result file is what? Dot class file. After compilation, Java program. After compiling Java it contains binary codes, not binary code. Here it's a byte code. Here it's a byte code. Byte code for Java program. Byte code for Java program. Okay. Next, yes, byte code for Java library. 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 Okay. So byte code for Java program. Okay, like C library, Java also having its own library here. Java, every application software has library here. C library, C++ library, Python library, .NET library, Java library, Hadoop library. Okay, like this, everything having its own library here. Library means it's a predefined one, predefined. Okay, so bytecode for Java program. Yes, bytecode for Java library. Next, binary code for OS library. No, don't have this part. Only this is simply dot class file. Okay, so dot class file. So dot class file, yes, here dot class file contains for bytecode for Java program, bytecode for Java library. See, Java library also developed in Java. Java library also developed in Java. So dot class, yes, simply not dot class. So what is exact dot class? A dot class is a, yes, is a pure Java program. Yes, Java dot class file. The dot class file is a pure Java program. Java program, pure Java program, pure Java program. Yes, in bytecode format. In bytecode format. In bytecode format. So what is exactly bytecode we'll discuss. What is bytecode? I'll explain in Java. So once Java programming started, I can explain clearly about bytecodes. Once Java programming started, okay, we can discuss. Okay, yes. So next topic is programming when it starts. After finishing topic, yes, next is Java installation, Eclipse, and programming and all the starts here. Okay. See here, so bytecode for Java program, bytecode for Java library, bytecode for Java library also developed in Java. So that means here dot class file is a pure Java program. Dot class file is a pure Java program in bytecode format. Okay, yes, you don't have any OS library. Dot class file don't have any OS library. Dot class file don't have any OS library. So any OS library. So dot class file. So you don't have any OS library. So dot class file is now free from OS library. Dot class file. Dot class file is free from OS library. Dot class file is free from OS library. So dot class file don't have. So dot class file, yes, you don't have any OS library. So dot class file is free from OS library. Free from OS library. Suppose for example here, test dot class. For example, test dot class file. Test dot class file prepared. Yes, prepared. Anyways, prepared and anyways. Yes, you don't have. Yes, you don't have. Yes, OS library. Don't have any OS library here. Yes, prepared, maybe prepared and anyways dot class file. Dot class file prepared and anyways, but you don't have any OS library. But you don't have. It don't have any OS library. It's a free from OS library. It don't have any OS library here. Fine. Now tested dot class file. Okay, tested dot class file working on different operations. Working on let us see like exe file tested dot class file also get different operations. Okay, tested dot class file. Tested dot class file working on different operations. Tested dot class file. Tested dot class file working on different operations. Let us see. Let us take different platforms. Yes, no. Yes, hardware, Windows OS, Windows library, not tested dot class file. Tested dot class file. Tested dot class file. Okay, so tested dot class file, not tested dot class file, and different. So this tested dot class file, tested dot class file placing an interface. After placing an interface, running. When you try to run this tested class file, what happens here? Yes, can we run this tested tested dot class file directly? No. This tested dot class file you can't run directly here. No, we can't run. So running test dot class directly can't run here. So reason here, see here tested dot class file has to communicate with hardware components, right? To communicate with hardware component, this tested dot class file also has to link with OS library, but it's not linked here. Tested dot class file don't have any OS library. It's free from OS library. Tested dot class file is free from OS library. It don't have any OS library. It don't have any OS library. Then how it can communicate with hardware components? No, it cannot. So this tested dot class file also has to link with OS library. Yes, we will link it. Someone has to link here. This tested dot class file should be linking with OS library, Windows OS library. Yes, we will link it here. Okay, this tested dot class, even Java program, this tested dot class file also has to link with OS library. So tested dot class file. Okay, tested dot class file also has to link with OS library. Yes, we will link it here. We will link it here. We will link it. Yes, for linking purpose between tested dot class file and Windows files. So one more layer come to picture. One more layer will come to picture here. So what is that layer? Anyone? Yes, anyone, can you guess it? Just I'm asking about your guessing here. So between tested dot class file, Windows OS library, to link the tested dot class file with Windows OS library. So one more layer will come to picture here. One more layer come to picture. What is that layer? Anyone, can you guess it? Anyone, can you guess it? Anyone, can you guess it? No, tested dot class file itself is having bytecode. That bytecode linking with OS library. Tested dot class file contains bytecode only. That bytecode has to link with OS library. Yes, for this purpose, one more layer come to the picture. What is that layer? Yes, it's a JVM. JVM. So JVM stands for Java Virtual Machine. JVM stands for Java Virtual Machine. Java, yes, Java Virtual Machine. JVM stands for Java Virtual Machine. JVM come to the picture. Now JVM taking tested dot class file. Simply JVM taking tested dot class file links with Windows OS library. Once linked with Windows OS library, communicates with the hardware components. Flexibly. Okay, so this tested dot class file simply linking to Windows OS library by the JVM. So once linked with Windows OS library, then execution and generating output here, successfully completing here. Okay, yes, some same tested dot class file running on another platform. Let us take another platform here. Running on another platform. Let us take another platform. Yes, Windows, no Linux platform. Linux platform. Linux base. Linux base with Linux library. Linux library. Right? Now here, what happens? Yes, here when you try to run test.class file, here also same thing happens here. Yes, what happens here? Here also JVM on Linux OS also this is JVM. So this Linux JVM taking test.class file links to Linux OS library. Once linked with Linux OS library, then communicates hardware, right? See same test.class file. If it is running on Windows OS, Windows JVM linking this test.class file to Windows OS library. Same test.class file if it is running a Linux phase. Linux JVM taking test.class file, linking with Linux OS library. Okay, so when OS changes, that link is changing, right? Then when OS changing, link is changing here. Okay, let us take one more platform. Yes, Mac OS. Mac OS with Mac library. Okay, Mac library. Okay, yes, on Mac OS of this is JVM. Now Mac JVM taking test.class for links to Mac OS library. So once linked here communicates with the hardware components. That's it. So what is happening here? Yes, every time of changing OS, that link is changing. Every time of changing OS, that link is changing, right? So JVM is responsible to link to current OS, linking to current OS, linking to current OS. So every time of changing OS, that link is changing. It is called dynamical linking. Dynamical linking. Okay, so dynamical linking here. Okay, see Java dot class file. Yes, Java dot class file dynamically means runtime. Java dot class file dynamically yes linking with OS library, OS library, OS library by the JVM. Okay, so Java dot class file dynamically linking with OS library by the JVM. Okay, yes, since it's dynamical linking with OS library here, okay, it's a independent platform. Dynamical linking. So every time of changing OS, that link is changing. Every time of changing OS, that link is changing. Yes, if it's running Windows OS, links to Windows OS library. Okay, see, dot class file don't have any OS library. Dot class file don't have any OS library. It's a free from OS library. Yes, if it is running on Windows OS, links to Windows library here. If it is running on Linux OS, links to Linux OS library. If it is running on Mac OS, yes, links to Mac library here. Mac library. So depends on OS here. Depends on OS that link changes. So link changes means dynamic linking. Okay. Since Java dot class file, dynamically linking with OS library by the JVM. Yes, it's an independent platform. It's an independent of OS. It's an independent of platform or OS. Anyone. Okay. It's an independent of platform. Independent platform. Okay, see here C programming, what happens here? In C programming, exe file, that link is fixed, right? Okay, yes, C program exe file. C program exe file prepared Windows OS, then it contains Windows OS library. Okay, here, yes, Linux OS library. So here again Windows OS library. So exe file always linking with OS library. It's a statical linking. Here. So exe file prepare Windows OS and it links with Windows OS library. All are linked. At the time of generating exe file itself, linking with OS library. So once linked, it's a fix. That link won't change. At the time of generating exe file itself, yes, at the time of generating exe file itself, linking with OS library, that link never changes. Here. It's a fix. That link is fixed. Okay, that link is fixed here. See, exe file statically linking with OS library here. Exe file statically linking with OS library. Since exe file is statically means fixed, that never changes. That link never changes. Once linked is done. Once linked, it's a fixed. Once link is done, it's a fixed. That link never changes. It's a fixed. That is statical linking. Okay. Yes. So since exe file is statically linking with OS library, it's a OS dependent. Okay. So exe file is statically linking. Since statical linking, yes, it's a OS dependent here. OS dependent. When come to Java, Yes, what happens here? Java dot class file dynamically linking with OS library by the JVM. Okay, it's a dynamical linking. So since dynamical linking, it's a independent platform. Okay, scenario wherever statical linking is there, statical linking, statically, statically linking means yes, statical linking. Then it's a OS dependent, OS dependent, OS dependent. It's a OS dependent. Okay, dynamical linking, dynamically, dynamical linking. Dynamical linking is a OS independent, OS independent, OS independent. Okay, see Java, Java and Python, Java and Python, yes, Java and Python. Okay, dynamical linking. Java and Python are dynamical linking. So dynamically, dynamical linking. Okay, since both are dynamically linking here, Java and Python both are independent platforms. Okay, Java and Python. Java and Python are dynamical linking with OS. So that's the reason Java and Python both are independent platform. Java and Python both are independent platform. Java and Python dynamical linking here, both are independent platform. Okay, fine. So statical linking means OS dependent, dynamical linking means OS independent, statically dependent, dynamically independent. Okay, that's okay, fine. Now here, see what I'm saying here. Windows Space Windows JVM taking test dot class file links with Windows Space library. Linux JVM, yes, taking test dot class links to Linux Space library. So Mac, here are the JVM taking test dot class file links Mac libraries. Now question is here. Windows having its own JVM, Linux having its own JVM. Yes, here Mac is having its own JVM. Now question is here. JVM, is it part of OS? JVM, is it part of OS? No. JVM is not a part of OS. JVM is not a part of OS. Okay, JVM is not a yes. JVM. See JVM is not a part of OS. JVM is not a part of OS. Then how getting JVM here? Yes. So Windows. Then from where we can get the JVM here? Yes, the JVM. Yeah, to run the tested dot class for compulsory JVM required. To run the Java program, JVM required. Without JVM, Java program cannot run here. JVM required. Then how can you get JVM? JVM is not a part of OS. JVM is not a part of OS. Then how can you get JVM here? Yes. JVM, yes. JVM is from JDK software. JDK software. JVM is from JDK software. JVM is from JDK software. JDK is a Java software. JDK stands for yes, Java Development Kit. Java Development Kit. Java Development Kit. Okay. So JVM from JDK software. Okay. Yes. Now, how can you get JVM here? To get the JVM, the JDK should be installed on your OS here. Okay. Yes. Here to get a JVM here, to get JVM, yes, we have to install. We have to install JDK software. JDK software. We have to install JDK software. JDK software on OS. Okay. To get JVM, we have to install JDK software on OS. So once JDK software installed, we can get the JVM. Okay. See, Sun Microsystems. See, Sun Microsystems systems have developed. Yes, they have developed. Yes, developed JVM for every OS. They have developed JVMs for every OS in the market. Okay, Sun Microsystems, they have developed, Sun Microsystems have developed JVM for different operations. JVM for every OS. Okay, JVM. So JVMs, there are JVMs for every OS in the market here. Okay, yes, JVM for Windows OS, JVM for Linux OS, JVM for Unix OS, Like that here, for every ways, they have developed separate JVM. Okay, so every ways, for every ways, yes, for every ways, they have developed separate JVM. Okay, for Windows based Windows JVM, for Linux based Linux JVM, yes, next Mac based Mac JVM. Right, okay. Yes. Next, one more important interesting point here. Interesting point. Interest point. Some interesting point here. Yes. See, Java program dot class file. Yes, is an independent of OS, right? Independent of OS. Right? But see, Java program dot class file is an independent of OS. But JVM is a OS dependent. JVM is a OS dependent. JVM is a OS dependent. Okay. Java program dot class file is an independent of OS. Independent of OS. But JVM is a OS dependent. JVM is a OS dependent. JVM is OS dependent. JVM is OS dependent. So why JVM OS dependent here? JVM is OS dependent. So why JVM OS dependent? Okay, reason here. Yes, JVM. Yes, JVM developed. JVM developed in C++. C++. Yes, it's a yes C++ exe. It's a C++ exe. It's a C++ exe. JVM developed in C++. JVM developed in C++. It's a C++ exe file. JVM is a C++ exe file. Okay, since exe file is dependent. Okay, yes. So JVM developed in C++. It's a C++ exe file. Okay, yes. So here, so Windows wise, see. So Windows wise separate JVM, Linux wise separate JVM. Okay, yes. Mac wise separate JVM. Now JVM is OS dependent, right? So here JDK for Windows wise. JDK for Windows wise must have Windows JVM, right? Suppose OS change, JVM changes. Now instead of JDK, yes, Windows or for Windows wise, Windows JDK must have Windows JVM. Linux JDK must have Linux JVM. Okay, right? Yes, JDK must have Mac JVM, right? Yes, since JVM changing for every ways, JDK also changes. JDK also changes here. So because of JVM changing, okay, depends on ways that JVM changing, right? JVM changing. Since JVM changing, JDK software also changing here. Okay, since JVM is OS dependent, yes, JDK also OS dependent. Yes, since yes, since JVM is OS dependent, OS dependent, OS dependent, OS dependent. Yes, JDK. Yes, JDK also OS dependent. OS dependent. Okay, OS dependent. That means same JDK will not work for all operations. Same JDK. Yes, same JDK cannot be used with different operations. Same JDK, yes, cannot be. Same JDK cannot be used with different operations. Cannot be used with different operations. Different operations. Same JDK cannot be used with different operations. Cannot be used with different operations. Okay. Yes. Windows is having its own JDK. Linux having its own JDK. See, for example, C drive. See, JDK 8 and 9. Windows 64-bit, right? Yeah, the JDK for Windows OS. JDK 9 for Windows OS. So the JDK cannot run with Linux OS. Yes, for Linux OS, separate JDK, you have to download it here. Okay. Yes, one check. Let me show that. Yes, downloads JDK 1.8. See, Java 8. Yes, Oracle side. This is see this JDK. Linux. This is Linux. This JDK downloads. JDK for Linux. This JDK for Linux OS. Next JDK for Mac OS. JDK for Mac OS, JDK for Solaris OS, JDK for Windows OS. Windows OS, right? There are different JDKs. Okay, different JDKs for different operations. So we should download separate JDK. Yes, you guys are not necessary to download here. Yes, in Drive all are available. Okay, I'll give the Drive access. So yesterday already given to some students here, and remaining students today I'll give the Drive access. Yesterday already given to some students Drive access. Today I'll give to some other students. Okay. Yes. Drive. In Drive all are available. Yes, this is your Drive. Yes, it's your Drive. Yes, MN Core Java here. All these available here. See, this is JDK 8, Java 8. Next Java 9. First we'll start with Java 8. Finally we'll go to Java 9 also. So Java 8, Java 8 and Eclipse. Java 8 is available, Eclipse available. Okay. Yes, next. Yes, this core Java document available. So document, Eclipse, JDK 8. Yes, next. This is all the material. Yes, these are class document. These class documents, Eclipse, Java 8. Next, some assignments, some examples, programs, list of programs. This is complete material. Okay. So this is right. So next topic is Java installation and Java programming. Yes. So this topic on Monday. Tomorrow Saturday. This Saturday. Yes, today Friday, right? Yes, Friday. This Saturday I'm not taking class. So yes, actually classes are your class are Monday to Saturday. Monday to Saturday, but this Saturday, yes, I have some unexpected work. This Saturday not taking class. Okay. Next week Saturday I'll take it definitely. So next class on Monday. Okay, so next class all the installations on Monday. Okay, so this is topic is Java installation. Okay, yes, developing programs. So writing programs. Programming starts from Monday. Programming starts. Okay, so next class on Monday. So Monday topic is Java installation and Eclipse. Eclipse. So this is. Okay, just a minute, 1 second. Yes, sir. See, for your batch, already WhatsApp group created. Yes, already communicating in the WhatsApp. Okay, last 4 classes shared in the WhatsApp. In group already shared. Okay, and the drive access also given. In drive, all softwares, even recordings also available. Recordings having separate drive. Recordings. Yes, recordings also drive access given. So this is MN Drive course of 8 Jan. So for last 4 classes recordings. Today's recording also I'll upload. I'll upload to Drive here as well as share in WhatsApp also. So this is your group. Yes, in group. Yes, last 3-4 classes share in group here. Yes, yesterday drive level access given. Now you can take from drive here. Yes, the drive access. So from the drive, you can take all the documents, software, everything can take from the drive here. Okay. Yeah, this is my WhatsApp number. Yes, 8179189123. My WhatsApp number. Share your details, your name, next WhatsApp course you are attending here. Course core Java. Yes, next time 8 a.m. Next your Gmail ID request. Okay, yes, still anyone to share your alert group. Alert group here. Yes. So minute to minute communication is there in the group here. Group communication, even individually communication also will be there. I'm sharing, yes, I'm communicating with every student. Not only group communication, even individually also I'm communicating here. Java students. Today morning started already. The communication. Yesterday communication. Wednesday. Yes, minute to minute communication is there. Okay, so this is my WhatsApp number. Share the details. I will add to this. Yeah. So that's all for today, guys. That's all for today. Yes, any doubts? So next class on Monday. So next class on Monday. Yes, same time. Same time with new link. Yes, that new link will be shared. Will be shared to yes your Gmail ID. Your Gmail ID. Yes, as well in WhatsApp group. In WhatsApp group. Okay. Yes. So same time with new link here. That new link will be shared. Will be shared to your Gmail ID as well in WhatsApp. WhatsApp. Okay. Yeah. So that's all for today. That's all. So thank you guys. Thank you guys. See you on Monday. Thank you. Have a great weekend.